All right, I'm going to walk you through how to build a real-time machine learning pipeline in Sumatra. And for this, we're going to use the example of a bank that's trying to stop fraudulent money transfers caused by account takeover. So I'll walk you through the full process from engineering new features on the platform to validating them interactively, then bringing the offline feature values into Python for model training, and finally deploying them as a real-time service. In Sumatra, you declare your real-time feature pipelines as code. This code transforms events sent from your application to Sumatra's API as JSON. In this example, we have 5 event types. Outgoing money transfers are the main events that we want to classify. We also have login and device update events to give us visibility into account takeover. Let's assume we already have a few risk signals in place for these money transfers, like is the person transferring to themselves, how much money has left the account, have these 2 accounts transferred in the past, and how many others are sending to the same account. To that, let's add some features of our own, starting with the login event. All right, so for this new feature, let's count the number of unique account IDs grouped by IP, where the IP failed to log in, say, the last 15 minutes. Now, for this feature to be useful to us, we need to make it available at the time of the money transfer. We can use the latest aggregate over the login stream to look up the IP failures for the IP's attempt to log in was successful over, say, the last 14 days. But it might even be better to take the max velocity in case the most recent isn't actually the most suspicious. All right, so that's our first new feature. How do we know if it's even going to return any reasonable values? For that, we want to validate it on a data set, which in Sumatra we call a timeline. This timeline has about 100,000 events of various types over a 6-month period. We bring that timeline together with our code in the workshop, where we can preview how the feature values look as a way to quickly debug. Starting with the login event, our failed by IP feature seems to be generating reasonable values, so let's switch over to money transfers. And looking at the final feature we created, we see some 0s and 1s. If we filter on it, we can see that we're definitely seeing some suspicious values. But does this new signal actually help our transfer model to detect fraud? For that, let's switch over to Python. So imagine you, as a data scientist, start by pulling recent disputed transfers. We connect to Sumatra's Python SDK. Then we do the key step, called materialization, which is where we take the timeline of 100,000 events and replay it through our latest code. So this kicks off a serverless job that aggregates historical data and does a point-in-time join to backfill our new features and return an enriched data frame with our new features in it. We join that data frame with our labels. Then we're going to keep track of 2 sets of features, the old ones and those plus our new one. We apply standard missing value replacement. We split the training set 80-20 based on time to prevent leakage. And finally, we train our random forest model. From the ROC curve, we can see that the new feature adds quite a bit of lift, but there's still some opportunity for improvement. So let's add another feature. This time we're going to look at the update trusted device event and see how long it's been since the trusted device was changed in terms of the number of days. We use the latest time aggregate for that. And looks like we have a missing paren. Okay. Back to the workshop. We do see lots of nulls because some accounts have not changed their trusted device. But we do see some non-null values too. So let's see how much lift we get from adding just our one new feature. Days since device update. We're going to go back and run everything from materialization forward. Again, this is running that backfill job with our one additional feature, which should finish pretty quick. And we see we're doing the same pipeline as before. Missing value replacement, train test split, finally training our random forest model. As you can see, our model gets significant lift from that one final feature. At this point, we're ready to put our new features into production, and we're not going to have to spend weeks translating and productionizing our research code. We can do it in just a few seconds. Let's switch over from the in-browser editor to using a local IDE, where our code is managed in a Git repo. With the Sumatra CLI, we can compare the local feature definitions with what is live in production. After confirming, our feature service is updated and serving our new features at scale and ready to be used in production models. So let's see our real-time service in action by sending an example money transfer event as a JSON payload. We'll grab this curl command to post to our endpoint. And we get back a JSON response, which includes our new features, days since device update, and max failed logins. All right, if you want to try this out for yourself, all the code for this demo is up on our GitHub. To connect to the service, you just need an API key, which you can get from going to our website, sumatra.ai, and entering your email there. Or you can send email to hello@sumatra.ai, and we're happy to set you up.